Hello and welcome to CDITechSummitIII. In today's session, we will discuss how you can modernize your data center with Cisco ACI Fabric technology. My name is Ralph Carter, and I'm the Chief Network Solutions Architect with CDI. I've been with the company for about 6 years, but about 22 years in the industry. Cisco ACI is one of my specialties, and I hope that you find this session motivating as you embark on your future data center refresh initiatives. I'm joined today by Matthias from Cisco. Matthias, can you share some quick background?
Yeah. Hello, welcome also from my side. Matthias Wessendorf. I'm a technical marketing engineer in the data center switching business unit, focusing primarily on fabric architectures like ACI and day 2 operations.
Awesome. All right, so let me quickly jump over to the agenda. So today we're going to be talking about how you can effectively achieve higher SLAs with workload mobility, implementing something called metro pooling with active-active data centers. I'm going to kind of go into what that's all about, and I'm also going to explain how you can quickly instantly implement network segmentation as you're migrating from a traditional network into an ACI fabric. How you can quickly implement network segmentation. And following that, we're going to go through ACI day 2 operations, where Matthias is going to kind of show you what Cisco is doing from a management monitoring for ACI. Okay, before we start, I just want to quickly present some of the offerings, some of the services that we provide at CDI here in our professional services. We provide design, implementation, migration, and day 2 operational support of Cisco ACI data centers. We provide also health checks for existing customers that have implemented Cisco ACI, as well as best practice assessments. So we leverage both tools that designs that Cisco has provided from a best practice standpoint, but also the experience that we have from the many years that we've been implementing. We also can provide a managed services offering where we can create structured support agreements with flexible SLAs. We have a number of customers taking advantage of that. If there are automation initiatives around, doing some Ansible or ServiceNow integration, we can definitely help you there. And then we are also partnered with Cisco Learning Partners, so that if you want to get more of an intro into Cisco ACI, more formal training, or advanced troubleshooting in day 2 operations, we can assist you at that point as well. The first use case that I'm going to be talking about is workload mobility with metro pooling. Okay, and this is based on a Cisco ACI multi-pod architecture. It can also be applied with an ACI multi-site architecture, but for this case, I'm going to be talking about multi-pod. So, and when I talk about multi-pod, it's more relevant to a metro area, right? So, for example, you have New Jersey data center, you have a New York data center. Their latency is fairly low because they're in the metro area. So somewhere up to 5 milliseconds. Now, multi-pod does support implementation up to 50 milliseconds, but we also have to factor in, will the application tolerate that higher latency? So we try to implement these technologies in a sub 5 millisecond range, somewhere between 1 and 2, but up to 5 milliseconds. So what I'm going to do quickly is just show you a traditional data center architecture, a very logical view of that, and I want to then show you how you can enhance this architecture with ACI multipod as an example. So let's talk about 2 common networks, right, in the data center. You have a VDI network where you have virtual desktops. You have an applications network where maybe you have multiple different applications kind of connected in there. So you have a compute infrastructure. Virtual desktops would be hosted on this compute infrastructure, and they would kind of connect into this VDI network. And then you may have internal applications. Now, some customers have different subnets defined for different tiers of applications, but this is just kind of an example where maybe some applications are grouped together under the same subnet, right? Not uncommon, seen in a lot of data centers. You also have a perimeter, right? So security. In this case, a lot of times there are a highly available pair of physical firewalls providing, that north-south, that ingress-egress security. And in a lot of cases, you have an internet connection, right? So, for example, that firewall may peer directly with an enterprise internet router that's running BGP with the ISP, or maybe it's just an ISP and your firewall's kind of connecting there. But regardless, there's some type of security public DMZ segment that kind of provides that connection, right? And that's kind of what I'm depicting here. So, and let's not forget our WAN, right? We have one or more WAN routers that ultimately connect into this data center core that provides the default gateway services for our virtual desktops and our internal applications, and then it kind of makes the decision, am I going to the internet, am I going to the WAN, am I going to servicing something locally, right? So I'm going to bring out Mr. Packet here just to kind of show a general traffic flow to kind of help you understand where I'm going with this. So Mr. Packet is going to inject a packet into this network, and we're going to establish communication between the virtual desktop and the internal application. So obviously, because they're on a different subnet, that packet is going to go to the default gateway. It's going to, ARP and everything's going to get engaged there. And then that default gateway, that default router, right, is going to perform inter-VLAN routing possibly here, and then forward that packet to the internal application. And that internal application is going to respond. Maybe it was a DNS request, maybe it was an LDAP request, maybe it was a file share of some sort, etc. And then that packet is going to come back to that default gateway and then down to the return to the virtual desktop. Now, if the virtual desktop wants to go out to the internet, then that communication will, go to that default gateway, right? Pass through the firewall, go to the internet, and then be returned back in the same manner, because obviously the firewall is doing some source NATing, so that traffic is going to return. Okay. Now let's not forget our data center in New York, right? Kind of a similar footprint, compute infrastructure, VDI network. We have a separate perimeter. Maybe we even have a different ISP, right? Maybe AT&T is only provided in New York. Maybe Verizon is only in New Jersey. Highly unlikely, but for this use case, let's just pretend that's the case, right? So what I'm going to do here is, this is a traditional data center architecture. How am I going to enhance this with Cisco ACI VXLAN software-defined data center architecture? One of the concepts here is with VXLAN, right, where I can now implement something called the Pervasive Gateway. So in traditional data center networking, what you have is a data center core, typically, or maybe a distribution layer, depending on how big your data center is, that's providing this gateway service. So if you have endpoints that are on different subnets, that communication always has to go to the core in order to get routed or switched and then back down onto the to wherever that destination endpoint is. With Cisco ACI VXLAN, we're now taking that layer 3 operation and we're basically bringing it down to the top of rack switches, so that if you have, for example, 100 different top of rack switches or ACI leaves, then what you can do is, if there are devices on different subnets, like in this case VDI network and applications that are localized to one or a pair of switches, that communication, that layer 3 operation doesn't ever leave those top of rack switches, right? So that kind of creates more efficient routing. So if I can do that in my New Jersey data center, I can also do that in my New York data center. And effectively, right, because in this case with the Pervasive Gateway, the same IP address and MAC of that subnet is programmed by the APIC controller on all the leaves, right? So if you have 100 leaves, all those leaves for wherever the application is in scope is programmed on those leaves, okay? So if we can do that within one data center, we can also do that in 2 data centers, effectively stretching this subnet, this internal application subnet across data centers. So that will allow me to move the workload from New Jersey to New York. And when I move the workload, I can do a simple vMotion. My latency allows for it, right? And in this particular case, there's no change to IP address. There's no change to DNS. Everything works perfectly. This enables metro clustering technology that's down at the compute storage layer. Now, why? Oh, well, before I say that, when the communication occurs here, for example, if this virtual desktop now wants to access this internal application, it's still going to hit its local default gateway, which is now on ACI, right, on that leaf. And then that packet will get VXLANed over to the other data center to reach its internal, to the same internal application. So technically, if I was to vMotion that workload, right, to the other data center, that communication is still maintained. And it's going to kind of respond in the same fashion back to that virtual desktop, right? Now, why would I want to do this? Well, maybe you have requirements to maintain compliance. For example, you want to do data center rotation. Maybe there's a compliance requirement where you have to rotate your applications between data centers every 6 months, right? We have a couple customers that have that requirement. Maybe you're performing maintenance where you're either upgrading, firmware or code or VMware, etc., or you're doing migrations where you need to move workloads between hosts, or you're upgrading network cards, or etc. Right? There's could be some kind of maintenance reason. Maybe there's an overload occurring. Maybe some applications are getting hit very hard where you need to perform a compute offload to another data center, right? And the latency allows for that. Maybe there's a disaster, right? Maybe there's some kind of problem with the infrastructure where now you have to operate it from another data center, right? These are all valid reasons for moving, being able to perform workload mobility. Now, typically in data centers, we have a private DMZ, right? We have our application network stretched, right? But a lot of times you also have a private DMZ that has, DMZ applications that are accessed publicly or even privately from your internal network that you want to have guarded through a perimeter firewall, right? So what we can also do is effectively extend that DMZ in the same way that we're extending our application network, and those DMZ applications can also be vMotioned or relocated on demand, right, on your DMZ layer. So for example, if the virtual desktop now wants to access a DMZ application, right, what would happen is the communication will still go to the default gateway and then get VXLANed over to the other data center and connect through the firewall in the New York data center on its way to the application. And then the application will respond in exactly the same, through the same path, and then VXLAN back to the data center. How is this happening? Well, ACI has something unique. It's called host route injection, where in this particular case, because the endpoint is identified in New York, it will ACI Fabric there will advertise that endpoint IP up to the layer, through its layer 3 out to the firewall, and then the firewall will propagate that information down so that you can maintain traffic symmetry through firewalls. We've done this for multiple customers, and it works very, very well. Okay, if I can extend my application network, my DMZ network, I can also extend my internet network where I can, or my ISP network, right? I can have my firewalls from the respective data centers connect to the same ISP circuit, right? So for example, if you have 2 internet providers in New Jersey and 2 internet providers in New York, if you implement this technology, what you can effectively do is save on those costs, because now those 2 circuits are shared between data centers, right? So the use case here is metro pooling. I'm pooling compute storage resources. I'm pooling firewall resources. I'm pooling internet resources. I'm creating a pool, and it's all performed in a metro area, and I'm definitely increasing my SLAs. And when communication occurs here, right, that packet is going to go to the perimeter firewall, and the firewall is then going to decide which internet circuit to take in the use case for the extension of the public DMZ where my internet connects. And the packet will go out to the internet, and it's always going to return back to the same firewall. Why? Source NAT. Okay. Now, if, for example, instead of having physical appliances, physical firewalls at the perimeter, if you had virtual appliances, maybe Cisco FTDs, right, FTDVs, what you can also do is if there's some type of, disruption to the data center, right, you can also effectively recover that virtual appliance in the other data center. And guess what? Everything is going to still operate because that firewall is going to be connected to the same public and private and DMZ networks, right? So there's pretty much full business continuity at that point from a perimeter layer. Okay, the second use case that I'm going to jump into is instant network segmentation with Cisco ACI. Now, a lot of InfoSec teams and organizations always have different initiatives to kind of create network segmentation, to be able to control how, maybe a virtual desktop infrastructure communicates with applications, or maybe different applications on different subnets need to communicate. And a lot of times these organizations, what they do is they either move the default gateway to the firewall, where it will work and it's a valid deployment, but it creates some bottleneck scenarios where now the firewall has to maintain all that throughput of inter-VLAN or inter-subnet routing, right? The other scenario is, well, let's put an agent on the endpoint, right? All valid, but I'm going to show you kind of how easy it is to kind of implement that same security posture with Cisco ACI, and that's basically through L4 through 7 service insertion, right? So basically, what we would do is we can take one firewall or IPS IDS device or a farm of them, right? Whether they're virtual or physical, and connect them on a different subnet into the ACI fabric. And technically, what happens here, I'm going to take Mr. Packet out. And what would happen is that, for example, if the virtual desktop wants to communicate with the internal application at this point, let's say we just migrated you from your traditional data center into an ACI fabric. Cisco ACI is your default gateway for your different subnets. What we can do is a quick, simple policy that takes any traffic to any traffic. And when that packet hits the default gateway, now note that I'm not changing the default gateway and I'm not moving it to the firewall in this case, but there's a policy in ACI that's going to policy-based redirect that packet to an NGFW for, for policy to see if there's, maybe I'm not worried about source and destination IP or, the 5-tuple, for example, but maybe I want to see if there's any threats. I want to see if there's any vulnerabilities that are trying to be exploited in this communication stream. Maybe I want to protect against zero-day malware, right? I want to look at everything, and I want to kind of, inspect it for these different security policies. So what happens is that the ACI fabric redirects the firewall to one firewall or IDS appliance, right? And then after inspection, it's going to send it back to its default gateway, right? Because this firewall has its own default gateway that's defined as the ACI fabric. And then that packet comes into the internal application, right? A clean, nice, malware-free packet. And then the internal application is going to respond. ACI is going to know exactly which firewall was used because there's a symmetric hash that occurs. It's going to send that packet back to the next generation firewall for inspection, and then it's going to return it on its way back to the virtual desktop. Now, when we implement ACI for you and we migrate your networks into ACI, well, guess what? You're going to get this value, this benefit, where we can carve off either a virtual context or a virtual instance of your maybe perimeter firewall and allocate it for this particular purpose. Now, we can also create firewalls across data centers, and they can be one metro pool of security appliances where these packets can be, hashed across different standalone firewalls. And we could also apply it in the use cases of the WAN. So, for example, if the packet was destined to a WAN device, the packet is going to hit the default gateway of the virtual desktop, as an example, and it could be the same thing for the internal application. And then the policy would redirect that packet to the NGFW for inspection to make sure that there's nothing malicious in the WAN on egress as well as on ingress, right? So once the packet clears, then it can hit the WAN, and on return from the WAN, same thing happens. That packet will get sent over to the firewall for inspection to make sure that there's nothing infectious from the WAN as it comes into the data center, and then back to the virtual desktop, right? So this is actually a very quick and effective way, and we've done this for multiple customers with very good results. And you also want to kind of keep that latency very low between data centers. So this can definitely, implement a super fast and simple network segmentation strategy. And on top of that, you don't have to worry about installing any endpoints. No agents are required. Now you can complement this architecture with some kind of endpoint, agent, maybe Cisco tetration, etc. Right? But this kind of, if you have requirements to kind of implement security as fast as possible, this is the way to go. Okay, I'm going to now turn it over to Matthias because he's excited about talking about how we can do some day two operations with Cisco, with the day two operations tools that he's going to talk about for the Cisco ACI fabric. So Matthias, I'm going to hand it over to you.
So perfect. Now let's talk a little bit about day two operation, because if you're moving into the next generation architecture, like Ralph was pointing out during his part, how can we efficiently operate that one, especially when we can, after the day zero, day one, when we get into the day-to-day operation, also called the day two operation, right? We all know in day zero, there's a lot of really nice stuff built into ACI to bring a fabric up, to configure it, to get it deployed, etc. In day one, you're adding more services to the fabric, and you start to earn money there, right? So you are offering services based on that fabric. And then day two is really everything around efficiently running that fabric, looking into troubleshooting, looking into monitoring, etc. Right? So this is really where you have the life cycle. Right? You plan, you predict, you change, you want to get the information you're getting out of the fabric to start to analyze them, to remediate certain issues, to predict where you need to grow, where you need to change, where you need to add new capabilities, like the use cases that Ralph was pointing out with the mid-row pooling. If you need more compute power, how do you predict that from the fabric's point of view? The challenges we're seeing today with the most networks is that we have a lot of old-style fragmented insights only. Right? You're using potentially syslog, SNMP traps. You do SNMP walk to gather information about statistics, etc. And then we all know this is a kind of round-robin format. We have their delays of 5 minutes or more, etc. Right? And you don't get end-to-end visibility. Right? With that one, you use SNMP, syslog, and potentially AAA for auditing. But how do you get a single pane of glass around this one to really figure out if something goes wrong? What is the root cause? Who is potentially impacted? How can I use that information to efficiently analyze it, to remediate that problems, or also implement changes? And how do I automate all of this? Right? This is the biggest problem we're seeing these days. If you run big networks and looking into that one, you have fragmented insights, you have potentially all the information, but you need a lot of very, very skilled people to get all of this together and correlate that manually. And then we have limited insights. But the limited insights is really, how do I know which path my packet is taking while I'm troubleshooting it, right? Is it taking this ingress leaf, going to the spine, going to the other leaf? Which ports is it doing? Do I have any issues there? What about the latency there, etc.? Right? Potentially, you can do that with NetFlow, but NetFlow statistics gathering, it's not real data plane insights. You could do that with something like span ports, but that's also one of the biggest challenges you're having, which ports to span, how to correlate all the data you're getting, right? So you need to know which ports you need to look into, which traffic you need to look into, right? So that's always a lot of challenges we're seeing. And also, with this current day two landscape, a lot of people have the issues that there is no one place to go, right? You don't have that one place where your operations guys are going, where your architects are going, right? So how can we do that one? So with that, let me introduce to you the Nexus Dashboard. The Nexus Dashboard, the idea there is, Nexus Dashboard is a unified platform. That's one place to go to handle your whole data center operation from the point of view of the fabric itself. Right? You onboard your fabrics to the Nexus Dashboard, and on top of Nexus Dashboard, we have services like Insights or the Orchestrator, the Data Broker, integrations towards ServiceNow, Splunk, etc. Right? So your operation people go to that one Nexus Dashboard. You see the health of your different fabrics, which could be ACI based, which could be cloud based if you use Cloud ACI, which could be DCNM based, right, for NXOS, so that you get all of that information, visualize that in the one platform called Nexus Dashboard, and leverage the services on top, like Insights, which is gathering the streaming telemetry information. So Nexus Dashboard, more than just a hosting platform for services, it's designed to be that one platform to interact for day two operation with your infrastructure itself. Now, if we're looking now a little bit more in detail into the Insights functionalities, right? With Nexus Dashboard Insights, what we do, there is one fundamental change. Instead of pulling the information from the switches, we program the switches to stream the information directly to that one place, Nexus to the Insights, right? So we stream the data So that means it is more kind of a distributed functionality. And also we leverage capabilities built into the ASICs. The first thing is, for example, looking into microbursts. Microbursts, we can detect them either by streaming all information to a central place, and then you compute it and figure out there's microburst. Or we use the built-in capabilities in the ASICs, of the cloud scale ASICs, to detect microburst and stream the microburst event to the central location, which is much more efficient. Functionalities like that are also putting filters on what kind of flows are you interested in, and the ASICs directly exporting that flows also reference that hardware telemetry directly to Insights so that we can really draw the path of the packet through the network based on the forwarding information of the ASICs, right? Which is a completely different story than what you potentially do with NetFlow. Now, we stream all that information continuously to Nexus Insights. What we do there, we correlate all of these informations, right? So we can tell you then, how is your network behaving? We can do so-called anomaly detection. An anomaly is something different from an alarm, from an error, right? Just think of, you have a BGP peering to the outside. For the BGP peering, you normally learn 5,000 routes. Now you drop 100 routes. This is not an alarm. That's not an error, right? But it is not normal. So we raise an anomaly and tell you, hey, on that peering, you lost 100 routes. Is this normal? Was this expected? Or is it something you have to look into? And then with all of that correlation and data enrichment, we can tell you who is impacted, right? For example, you have packet drop on a link. What are the endpoints that are learned behind that link that are potentially impacted by that one? Or monitoring flows and seeing, okay, now I have issues with my latency. We can tell you which endpoints, which traffic is impacted for that latency, or you have packet drop, right? This helps you to turn on demand the capturing of the flows to figure out how do they run through the network and enrich all of that with the statistics of the interfaces, with the information we get from the switches to see which endpoints are learned. Did that endpoints move EDC? So we get all of this together and present that in that one tool in the Nexus Dashboard Insights running on the Nexus Dashboard. Right? Now, with all of that information, you can go via the Nexus Dashboard to see the health of your fabrics, to see what kind of issues do I potentially have, to drill into if you're troubleshooting something, if a case is getting opened, to look into that one. But then, of course, we can use this capabilities also to export these informations to other services like ServiceNow, to open tickets for anomalies, to put it into Splunk if you use Splunk for bigger integration in your monitoring system in the landscape, right? You can leverage a REST API. You can leverage also the Kafka bus built into the product to stream that information out, right? So with that one, I would give it back to Ralph. I hope you got some good ideas about how we are doing for the day 2 operation, with a lot of correlation with the artificial intelligence, machine learning, to figure out what are the different the normal behavior, what are the anomalies, etc., so that you have only a single place to go via the Nexus Dashboard and the Insights capabilities on top of Nexus Dashboard for your fabrics. Thank you, Rob.
Thank you so much for that, Matthias. That was cool stuff, very cool stuff, very innovative. All right, so I just want to thank you all for viewing this session. Please let us know if you'd like any more information of how Cisco ACI and the day 2 operations that ACI can offer, how it could greatly enhance your overall data center. If there's any interest, please let us know, and we could definitely dive a lot deeper into these technologies around multi-pod, around the multi-site, around service firewall integration, around day 2 operations. So please contact your CDI account manager or contact us through the CDILLC.com website. Thank you all for viewing.